get the 8 out of there. This number in base 10 is 3,471, the way we understand 3,471. This right here is actually the number 9. So do y'all remember we turning the light switches on and off in here and talking about computers, either no on or off, on or off, on or off? Okay? When you think of a number, if you go and you dial your friend's phone number, no one does that, right? You don't even know your friend's phone numbers, right? You just, okay, so let's say you hit the number 9 on your keyboard or on your calculator, or you hit it on your phone or on a computer, you hit the number 9. The computer has no idea that you hit the number 9. The computer sees this. Zeros and ones. It's on and off switches. That's all it is. So this is called base 2. This is called binary. Binary, because binary means there's only 2 options. 0, 1, 0, 1, 0, 1. All right? So I guess what the main kind of big takeaway from this is this. Base 10 is very important to us because this is the number system that you are raised with. This is what you're born, you're taught this, right? Base 10. But we could have, if we wanted to, we could have never shown you base 10, only shown you base 2, and then your understanding of numbers would be completely different. It would be based on this. Like right now, this makes complete sense to you. This seems foreign. But if we had chosen to do base 2 instead of base 10, this would look completely natural to you, and this would look like, what the, you know? You'd be like, what is this shit? That doesn't make any sense. So my final question to you is this. Why do you think we chose base 10? Because you could have base 8, base 7, you could have base 16. Actually, there is a base 16. It's called hexadecimal. Base 2. We could have used any base we want. Why did we choose to do base 10? Anyone have a guess? I mean, why base 10? Why did humans choose to use base 10? Think about it. It's only easy because it's all you've ever known. That's what I'm trying to say, is that if this is all you ever knew, you would say that's easy, and you'd say this is complicated. Right now, this is what you know, so that looks complicated. If we ever meet an alien species, I'm willing to bet they are probably not using base 10. They're probably using some other base. They could be using base 10, but that would depend on their physical characteristics. So why do you think we use base 10? We've got 10 fingers. That's it. We have 10 fingers, right? It's natural for us to go and have 10, right? To want to do everything in 10. It's very natural. If we were born with 8 fingers, let's say, I mean, we need the thumbs. If we don't have thumbs, we're not even dominating the planet, all right? So we need the thumbs. But let's say we take away another finger, okay? We had only had 8 fingers, let's say. We're going to be in base 8, I promise. That's what would have happened. If we meet some alien species, they come down and they have 12 fingers, I guarantee they're going to be base 12. Because that's just the natural way that we want to count, right? Does that make sense to you? So that's it. That's the only reason we do base 10. But that is why the exponential function 10 to the x is so important to us. This is such a special base to us because, well, shit, it's the one we use, it's the system we use, right? If you want to do 8 to the x, well, that, yeah, we could work with that, but that's really not as important because that's not the number system we're in. But number systems are arbitrary, right? Can I say one more thing? Can I? What if we were base 16? This is the part that I think will blow your mind a little bit. Base 2, there's only 2 options, right? Base 10, those are our 10 options. Base 16, there's how many options? 16 still. Right? Base 10, there's 10 options, right? These are the options for each digit, right? For base 2, these are the 2 options for each digit. If we were base 16, okay, so imagine I'm trying to create a number, right? 1, 2, 3, so let's say a 4-digit number, and I'm in base 16. I have 16 options here, right? Let's list out what the options would be. I could do in here a 0, a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, and then what? Can't do 10 because 10 is 2 digits, right? 10 is 2 digits. It's a 1 and a 0. So this can only have a single symbol in here. You can't use 10. Can't. So we actually start using letters. A, B, C, D. So where were we? 10, 11, 12, 13, 14, 15, 16. All right. Yes? Just see if you can follow. This is crazy shit right here. Okay, so watch. I'm going to give you a base 16 hexadecimal number. You ready? In this slot, I can do anything I want here. Okay, so let's keep this simple. I'm going to put a 3 here. Okay? And my next slot, I'm going to do something weird. I'm going to put C there. And then in my next slot, I'm going to put, let's say, 2. And in my last slot, I'm going to put E. This is a number, okay? That is a number in base 16. Here's what it is. This is 3 what to the what? Follow this pattern. 16 to the zeros. Okay, plus, now this one is C. Well, C was what? 1, 2, 9, 10, 11, 12. That means we have 12, 16 to the ones. Does that make sense? C means 12, 12, 16 to the ones. Then here we have 2, what? 16 squareds. Almost done. And here we have E. What was E? See, 9, 10, 11, 12, 13, 14, right? Wait, hold on. This was 10. Sorry, this was 10. Hold on. 1, 2, 3, 4, 5, 6, 7. So what was it? 11, 12, 13, 14, 15. Wait, I'm counting wrong. 10, 11, 12, 13, 14, 15, right? 15? Yeah. Okay. And then this one, 12, 9, 10, 11, 12. Yeah, okay. So 15, what? 16 to the thirds. Where's my calculator? I'm going to do this on my calculator. I'm going to do 16 to the third. C was 13, 9.
Isn't it 10, 11, 12,
10, 11, 12.
But is it 9, 10, and then 11, 12, 13?
No, that's the position of it. So 0 still means you have none of them. 1 of them, 2 of them, 3 of them, 4, 5, 6, 7, 8, 9, 10 of them, 11, 12, 13, 14, 15.
So
right?
Would E be 14 then?
10. Wait a minute. Now I'm confusing myself. Okay, this is 9 of them, right? 10, 11, 12. That's right. Okay, 12, 13, 14. Okay, I know I miscounted that one. Yes, that's 14. Let me do this. So that times 14. So this is 57,344 plus, let's see, 16 squared times 2, 512, plus 12 times 16, 192. And then 16 to the 0 is 1, so plus 3. So plus 3 plus 512 plus 5, 3, 4, 4. This is actually the number 58,051. E2C3 is 58,051 in base 16, right? So you can go any base you want. In any base that you ever would want, you can use. All right, so I need to somehow make this worth it to you for making you sit through this. I was really just trying to get you to see that base 10 is the important one because we have 10 fingers. So let me put up your homework assignment, okay? I want you to solve some equations for homework. I'll think about what I can do to make this worth it to you, this whole base conversation. Have any of you ever seen that movie Martian with, what's his name, Matt Damon, where he's stuck on Mars? Have you all seen that? Martian? It's like came out within the last like 5-6 years. No? Anyway, he's stuck on Mars and he's trying to communicate with people on Earth, and he has to use hexadecimal to do it because, yeah, well, if you haven't seen the movie, don't worry about it. Okay, so here's homework problems. You don't need to do anything out of the packet. I'm just going to give you some things to solve. All of these solve these equations. 5 to the x equals 32. 5 to the negative 4x equals 32. 5 to the negative 4x plus 3 equals 32. Let's see here. 5 to the negative 4x plus 3 minus 7 equals 32. 3 times 5 raised to the 4x plus 3 minus 7 equals 32. So all those problems just kind of start off simple, and then they kind of get more and more complex as you go. All right, and then 6, you put $10,000 into account. It's simple interest, okay? Account for 12 years. What rate do you need to have, let's say, $16,500? Y'all can take a picture if you want. All right, that's it. We're done for the day. Please have that ready for next Tuesday, because we're not going to meet face-to-face on Thursday, right? We'll be on Zoom. But next week, turn that in. That way I can give you, it's like a free